Hello, welcome back to Math Boot Camp. I'm Lloyd Gross from the Genesee Community College Learning Center. And in this segment, we're going to talk about divisibility rules. First of all, I have a question for you. Where do you put your winter boots when it's winter? Do they float randomly around your house or do you put them right by the back door? Most of us put them right next to the door. So, they're ready when we need to use them. Because if you had to hunt for your boots every time that you wanted to go outside, that would be really annoying. This is why we learn divisibility rules. Divisibility rules kind of like having a hammer in your toolkit. It's a math tool. You're going to stick it in your toolbox every time you work with, like working with fractions, with radicals, with equations, so many different math operations. You're going to pull out this particular hammer and it's going to help you get the job done. So what are divisibility rules? Well, mathematicians that are smarter than you and me have figured out quick and easy little tricks for figuring out whether a large number is evenly divisible by a smaller one. So let's start with a familiar example. You may know this one. A number is divisible by 10 if the last digit is 0. So our first number here is divisible by 10, and the second number is not. And many of us remember that one. There's also divisible by 2. Many of us remember that one pretty easily by heart. I know it by heart. A number is divisible by 2 if the last digit is even. So if it's 0, 2, 4, 6, or 8 at the end of the number, then the whole number I know is evenly divisible by 2. Try another one. Not too bad. Divisibility by 5. Is the last digit a 0 or a 5? And if it is, well, then we know the whole number is divisible by 5. So those are the ones that are really simple, and we tend to memorize them and keep them with us for life. Let's talk about some of the less popular ones, some of the ones that you may have forgotten or maybe you never learned them in the first place. Let's talk about them. So divisibility by 4. A number is divisible by 4 if the last two digits form a number that is also divisible by 4. So we have 123,532. The last two digits are 32. Can I divide 4 into 32? Sure I can. Goes in 8 times, nice and even. That means that that whole number is evenly divisible by 4. And what about divisibility by 8? Divisibility by 8 is if the last 3 digits form a number that's also divisible by 8. So in our first example, 880, divisible by 8 11 times. 533 is not divisible by 8. So that second number, the whole number is not evenly divisible by 8. So 2, 4, 5, 8, 10, all very similar rules. And if you practice them for a bit, you'll catch on. Now, 3 is a very simple rule, but a very different rule. If the sum of the digits in a number is divisible by 3, then the whole number is divisible by 3. So what I have to do here is take these digits, treat them as separate numbers, and add them up. So 1 plus 2 plus 3 plus 5 plus 3 plus 4 is 18. Is 18 divisible by 3? Yes, 6 times. Is 18 divisible by 9? Yes, 2 times. Therefore, that first number, 123,534, is evenly divisible by both 3 and 9. It's kind of weird, right? But it works. Every single time it works. And once you get used to it, it's so much faster and easier than trying to hand divide. Yes, there are divisibility rules for 7 and 11. They're strange. They're almost as much effort as just trying to divide it out. If you want to try and work with those, go for it. I don't use them and I'm not going to cover them. Here are the ones that are really, really important. Okay. The divisibility rules for your small primes, 2, 3, 5, 7. Those are the big ones. 7, very often I'll just hand divide, but if you want to learn the rule, you can. And when we're going to use them, well, we will use them when we are simplifying fractions. We're going to use them when we're trying to find greatest common factor in polynomials. We're going to use them when we're trying to simplify radicals. We're going to use them all kinds of different places. So this little chart here, this is sort of like your hammer. Why do you want to use a hammer properly? Well, not because using a hammer by itself is useful, but because it lets you build things. So try this out with some sample numbers and practice until you can do it without thinking. And then you're going to find that the rest of your math goes a lot faster.